Dark matter and dark energy, the invisible universe. Introduction. Look up at the night sky on a clear evening, perhaps out in the countryside, away from the glow of London or Manchester. You'll see thousands of stars twinkling, maybe even the Milky Way stretching faintly across the sky. It feels endless. But here's the strange truth. Everything you see up there, the stars, the planets, even us here on Earth, makes up just 5% of the universe. The other 95%, it's invisible. We can't see it. We can't touch it. We only know it's there because of the way it bends, pulls, and shapes the universe around us. Scientists call it dark matter and dark energy. Dark matter acts like an invisible glue, holding galaxies together. Dark energy is even more mysterious. It's what's driving the universe to expand faster and faster, as if some unseen hand is pushing everything apart. For decades, astronomers, including many right here in the UK and Europe, have been chasing these cosmic ghosts, and what they've discovered is stranger than any science fiction story. In this journey, we're going to step into the invisible universe, what dark matter and dark energy are, how we discovered them, and why they might hold the ultimate secret about the fate of everything. So, let's dive into the unknown. What is dark matter? Now, let's start with dark matter. The phrase itself sounds like something out of Doctor Who, mysterious, hidden, maybe even dangerous. But, in truth, dark matter is simply the name we give to something we can't see, yet we know must exist. Here's why. In the 1930s, astronomers studying galaxies noticed something strange. When they measured how fast stars were orbiting around the center of their galaxies, the maths didn't add up. According to the laws of physics, those galaxies should have been tearing themselves apart. The stars were moving far too quickly for the visible matter, the stars, gas, and dust, to hold them together with gravity. It's like watching the London Eye spin too fast, and somehow the capsules don't fly off into the Thames. You'd immediately think, there must be something else keeping it stable. That something else is what we now call dark matter. It doesn't give off light, it doesn't absorb light, and it doesn't interact with normal matter in any way we can detect, except through gravity. Think of it as an invisible scaffolding that surrounds galaxies, keeping them bound together. Without it, the Milky Way and every other galaxy would simply unravel. Scientists estimate that dark matter makes up about 27% of the universe. That's more than 5 times as much as all the ordinary matter stars, planets, and people combined. But here's the catch. We still don't know what dark matter actually is. It could be a completely new type of particle, something beyond our current understanding of physics. Ideas range from WIMP's weakly interacting massive particles to XINs, exotic particles that are just theory for now. Here in the UK and across Europe, scientists have been deeply involved in the search. From underground laboratories and old mines, where detectors wait in silence for the faintest sign of a dark matter particle, to huge experiments at CERN near Geneva. The hunt is ongoing. The mystery of dark matter is a humbling reminder. We are surrounded by an unseen universe, shaping our galaxies and even our lives, without us ever being aware of it. Dark energy, the universe's mysterious expansion. If dark matter is the invisible glue that holds galaxies together, then dark energy is the opposite, an invisible force that pushes the universe apart. For a long time, scientists assumed the expansion of the universe, which began with the Big Bang, would gradually slow down over billions of years. Gravity, after all, should eventually tug everything back together, or at least put on the brakes. But in the late 1990s, 2 teams of astronomers studying distant exploding stars, called supernova, made a shocking discovery. Instead of slowing down, the universe's expansion was actually speeding up. It was as if someone had pressed the accelerator pedal on the cosmos to explain this bizarre behavior. Scientists proposed the existence of dark energy, a mysterious form of energy that seems to permeate all of space, working against gravity, pushing galaxies apart faster and faster. The scale of it is dark energy is thought to make up nearly 68% of the entire universe. That means most of the cosmos isn't made of matter at all, dark or otherwise, but of this strange, invisible energy we barely understand. To picture it, imagine blowing up a balloon. Normally, you expect the balloon to slow down as it stretches. But now imagine the balloon starts inflating faster and faster on its own, with no extra air being added. That's what dark energy is doing to the universe, stretching space itself at an ever-quickening pace. We don't know exactly what dark energy is. Some theories suggest it could be linked to the very fabric of space, a kind of vacuum energy that naturally exists even in complete emptiness. Others think it might be a new, undiscovered field of physics. But here's the unsettling part. The way dark energy behaves could decide the ultimate fate of the universe. Will the cosmos keep expanding forever, growing colder and lonelier in what scientists call the Big Freeze? Or could dark energy become so powerful that it eventually rips galaxies, stars, planets, and even atoms apart, a scenario known as the Big Rip? Whatever the outcome, dark energy is a reminder that the universe isn't just expanding, it's evolving in ways we're only beginning to glimpse. And here in the UK, with projects like the European Space Agency's Euclid telescope launched to map the influence of dark energy across billions of galaxies, we're part of this quest to unlock one of the greatest mysteries in science. Dark energy is invisible, unstoppable, and, at least for now, unexplainable. Yet it may be the single most important force shaping the future of everything we know. How do we know it exists? Whenever you hear scientists talk about dark matter and dark energy, it's natural to ask, if we can't see them, how do we know they're even real? After all, extraordinary claims demand extraordinary evidence. The answer lies in careful observation. The way the universe behaves simply doesn't make sense without them. Let's start with dark matter. One of the biggest clues comes from the way galaxies spin. As we said earlier, stars at the edges of galaxies move far too quickly. According to Newton's laws of motion and gravity, they should fly out into space. But they don't. Something unseen is providing the extra gravity to hold them in place. Then there's gravitational lensing, one of the most beautiful conformations of dark matter. Einstein predicted that massive objects bend light, almost like a magnifying glass. And when astronomers look at distant galaxies and galaxy clusters, they see this bending effect. But the amount of visible matter isn't enough to account for the distortion. It's as if something invisible, huge amounts of it, is warping spacetime. That invisible mass is dark matter. Now, what about dark energy? The evidence comes from watching the universe itself expand. Back in 1929, Edwin Hubble discovered that galaxies are moving away from us, proof that the universe is expanding. Decades later, in the 1990s, astronomers using supernova as cosmic distance markers found that galaxies were moving away faster than expected, showing that the expansion of the universe is accelerating. The simplest explanation, a mysterious force, which we now call dark energy, is driving it. More proof comes from the cosmic microwave background, the faint afterglow of the Big Bang, mapped in detail by satellites like NASA's WMAP and the European Space Agency's Planck mission. The tiny fluctuations in this ancient light reveal the universe's composition, and the numbers add up only if dark matter and dark energy are included. To put it another way, without dark matter and dark energy, the universe we observe makes no sense. Galaxies wouldn't form the way they do, the expansion wouldn't behave the way it does, and the cosmic background radiation wouldn't look the way it does here in Europe. British scientists have been at the heart of these discoveries. The Euclid Space Telescope, launched by ESA with major UK involvement, is mapping billions of galaxies to trace how dark energy and dark matter shaped the universe over time. It's like building the most detailed cosmic atlas ever made, And every new page deepens the mystery. So while we can't yet hold a particle of dark matter in our hands, or bottle a drop of dark energy in a lab, the fingerprints are everywhere. The universe itself is the evidence. The big questions by now. We know that dark matter and dark energy make up around 95% of the universe. Yet here's the astonishing truth. We don't actually know what either of them are. This leads us to some of the biggest questions in modern science. Let's start with dark matter. Is it a new kind of particle we've never detected before? Some scientists are searching for WIMPs, weakly interacting massive particles, which might drift silently through us every second, without us ever noticing. Others propose EXIONs, strange, ultralight particles that could fill the universe like an invisible fog. Then there's an even wilder idea. Perhaps our understanding of gravity itself is incomplete, and what we call dark matter is really a sign that Einstein's theory needs rewriting. Now, consider dark energy. Is it a property of empty space, the so-called vacuum energy? Or is it a completely new field, a hidden force that we've never encountered in everyday life? Could it even change over time, growing stronger or weaker, reshaping the destiny of the cosmos as it evolves? And that brings us to the ultimate question. What is the fate of the universe? If dark energy continues as it is, the cosmos will keep expanding forever. Galaxies will drift farther and farther apart. Stars will burn out, and the universe will end in a cold, dark emptiness, the big freeze. But if dark energy grows stronger, the consequences could be even more dramatic. In billions of years, its repulsive force might overpower gravity completely, tearing galaxies, stars, planets, even atoms themselves, apart. Scientists call this apocalyptic scenario the Big Rip. On the other hand, if dark energy somehow weakens, gravity might one day regain control. The expansion could slow, stop, and eventually reverse, leading to a colossal collapse of everything back into a single point, the Big Crunch. These are not just abstract theories. They are fundamental questions about where we came from, what the universe is made of, and where it's heading. And the answers could reshape not just our understanding of physics, but our place in the cosmos. What's inspiring is that UK and European scientists are right at the heart of the search for answers. From deep underground labs hunting for dark matter particles, to space telescopes scanning billions of galaxies for signs of dark energy. The quest is ongoing, and while we may not yet have the final answers, asking these questions reminds us that the universe is far stranger and far more mysterious than we ever imagined. So where does this leave us? We've journeyed through the visible universe, the stars, the galaxies, the planets, and beyond, into the vast invisible realm of dark matter and dark energy. Together, they make up 95% of everything, yet remain two of the greatest mysteries in all of science. Dark matter holds galaxies together, unseen but essential. Dark energy drives the universe apart, unstoppable and mysterious. Both shape the cosmos in ways we can measure, but still can't fully explain. And maybe that's the most exciting part, because every great scientific discovery begins with a mystery. A century ago, we didn't know about black holes. 50 years ago, we had no idea the universe's expansion was accelerating. What might we discover in the next 50? Right now, UK and European scientists are part of this global adventure, from the Euclid space telescope scanning the heavens, to underground detectors waiting for the faintest whisper of a dark matter particle. Each experiment is a step closer to uncovering the truth, but until we solve it, dark matter and dark energy remain a powerful reminder. The universe is far bigger, stranger, and more mysterious than we can yet imagine. So the next time you look up at the night sky, remember this: what you see is only a tiny fraction. The real story of the universe is still hidden in the dark, and perhaps, in our lifetime, we'll finally switch on the light